No, I'm ready to go home.
Wish it was 316.
Yeah, that'd be nice. Wouldn't it? Yeah, all of that. All right, just a few pages and we'll be done. Um, everybody good with their notes? All right. Inference sampling. The purpose of a sample is to give us info. Right where we left off. About a larger population. The process of drawing conclusions about a population on the basis of sample data is called inference. Because we infer information about the population from what we know about the sample. Inference from convenience samples. Or voluntary response would be misleading because these methods of choosing samples are biased. We are almost certain that the sample doesn't fairly represent the population. The first reason to rely on random sampling is to avoid bias. So why do we random sample? To avoid bias. All right, so what you see here in this little chart or this little dot plot is 500 SRSs of size 100. So what they did was from the population, they took an SRS of 100. So they put, let me explain it a little better, 500 slips of paper in a hat, and they drew out 100. And then they replaced them, and then they did it again. And then they did it again, and did it again, and did it again. Got it? So they just repeat it over and over and over again. So that's what this is. So each time they may have gotten the same mean or they may have gotten a different mean. Okay, so that's what you were doing yesterday with your sunflowers. So when those of you that have already done it, thank you for turning it in. Those of you that are having a little bit of trouble, we'll talk about it. But that mean is what you're looking for. And you're looking for the difference in the means based on the way you sampled. Okay, so that's all it is. So for this, the center is approximately 0.72. But if you look, each one of them pretty much has a different, not all of them have the same 0.72. So every time you draw out of the hat, you're not going to get the same mean, okay? So every time you sampled yesterday, you shouldn't have got the same mean of sunflowers. Could you? Could you? Yes, but it's likely that you don't.
Like you should back here.
The shape, what kind of shape is this? Keep going then. Symmetric, yep. You can absolutely say unimodal, that's fine. And then we also have a spread of 0.56 to about 0.83. Right, so again, all of that is the plots of 500 SRSs from a size of 100. We flip it over. Why do we random sample? The results of random sampling change haphazardly from sample to sample. And then the laws of probability. Allow trustworthy inference. About the population. All right, here's something you're going to need to know for the rest of the year. Larger random samples give better information about the population than smaller ones. Larger samples decrease variability. Okay, so the larger the sample, the less variability. All right. So what happens if we increase the sample size in the last example from 100 to 400? So now they're drawing 400 students out of the hat instead of 100. So look at what happened to our little chart. This again is taking 500 samples. So put them in the hat, pulling out one time, put it back in, pull out 2 times, put it back in, pull out 3 times. They did it 500 times and they pulled out 400 each time. Yes, it is the same population. So what happened? Just looking at this, what happened? Yeah, the spread got, what is spread? Yeah, spread, range, what is a good word for that? Variability is what I'm looking for. Yeah, variability. So what happened to our variability? It decreased, right? So the larger the sample size, the smaller the variation. And you guys can see it in this graph. So now what happened was the graph is centered at 0.7 before it was 0.72. So that didn't change much, right? So your center's not really going to change, but what is going to change is that now they fall between 0.63 and 0.76. So it squished it up a lot. So the difference between the sample proportion and the population proportion is at most 0.13. That 0.13 comes from the 0.76 minus 0.63. All right. When using SRSs of size 100, this difference could be as much as 0.15. So when we look back, the range, we subtracted that and we would have got 0.15. The moral of this story, by taking a very large random sample, you can be confident that the same result is very close to the truth about the population. One more time. Larger sample reduces variability. Okay. So if we take sample surveys, what could go wrong? The first thing that could go wrong, the use of bad sampling methods. What are some bad sampling methods? Convenience and? Voluntary response. Often leads to what? Why don't we do those? Bias, absolutely. Researchers can avoid bad methods by using random sampling to choose their samples. Other problems are more difficult to avoid, and we'll talk about those other problems later on. Okay. So use the correct sampling method to avoid bias. If you do the other two, you're going to have bias. Sampling is often done using a list of individuals in the population. Such lists are seldom accurate. Or complete. This result is under coverage. Okay, I'll give you a good example. Y'all were just talking about telemarketers calling. Why would that be under coverage? Say it loud. Okay, do you know what loud means? You're fine, say it. I just can't hear you. Okay, maybe, but we're talking about the population. Telemarketers are using what? A call list, right? Is everybody on that call list? What if they're using call lists for cell phone? What are you missing? Landlines, right? Any kind of landline. So that causes that under coverage. So anytime that you're doing that, to get an accurate and complete list is going to be really, really hard. Maybe somebody used the phone book. Okay. Not everybody's phone number's in there. Got it? All right. So how do you get on the call list? You have to get, you're always on there. You have to get on the do not call list. All right. Undercoverage occurs when some members of the population cannot be chosen in the sample. Okay. So like I said, if they go by phone numbers, if somebody's on the do not call list, they cannot be chosen. Or if it's from the phone book, typically those are landlines. If people have cell phones, they won't be. I don't have a landline. Most samples suffer from some degree of undercoverage. A sample survey of households, for example, will miss not only homeless people, but also prison inmates and students in dormitories. A phone survey may miss cellular users if they only have a list of landlines. The results of national sample surveys have some bias due to undercoverage. If the people not covered differ from the rest of the population. Well-designed sample surveys avoid bias in the sampling process. The real problems start after the sample is chosen. One of the most serious sources of bias in a sample survey is non-response. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. Be careful because some students misuse the term voluntary response. Sorry, I can't write today. To explain why certain individuals don't respond in a sample survey. Think of it this way, non-response can occur only after the sample has been selected. So you want to create a survey, you pick your sample, you put the survey out there, and the people in the sample don't turn the survey back in. That is non-response. Non-response is not that you didn't give them the survey. Got it? So that's all it's trying to say. All right. In a voluntary response sample, every individual has opted to take part, so there can't be any non-response. So make sure if it's a voluntary response, you don't say that it's biased due to non-response. All right, the ACS, GSS, and opinion polls. Another type of non-sampling problem. Occurs when people give inaccurate answers. Like when you don't take a sample. So you create a survey for this school that talks about like sensitive subjects. So Do you partake in drugs or alcohol outside of school? Is everybody going to answer? Will they answer honestly? You see what I'm saying? So that non-sampling problem that occurred, inaccurate answers because people will lie about things like that. And why would they lie about that? So they don't look bad, so they don't get judged. Correct. You're absolutely right. All right. The gender, race, age. Ethnicity. Or behavior of the interviewer can also affect people's responses. Just for example, again, person walks in, tatted up, pierced up, dreads, to an interview, a business interview. What do you think is going to happen? Are they qualified? Quite possibly, right? So that's exactly what they're trying to say here. Okay, so if the interviewer looks like that, are you going to be a little more timid? Now ask it this way. Same question that I just said, the survey that I just said to your peers. If I give the survey versus if you give the survey, what are the chances of the differences in the responses? So if I survey you guys about your extracurricular activities, what are the chances that you're going to be honest and open with me, like everybody that I survey, compared to if one of you give the survey? Does that make sense? So that's exactly what it's saying. So that's one of those age things, like depends on the interviewer. All right. A systematic pattern of inaccurate answers in a survey leads to response bias. So I may give that survey and I may get that 50% of the population partakes after school in drugs and alcohol. You may get it and get a higher amount because they're more truthful with you. Okay, that's all it's saying. So mine was a little more biased than yours was. All right. How do Americans feel about illegal immigrants? Question wording matters. Question wording matters. Even the order in which the questions are asked matters. Don't trust the result of a sample survey until you have read the exact questions asked. Ask a sample of college students these two questions. How happy are you with your life in general? Answer on a scale of 1 to 5. How many dates did you have last month? There is almost no association when asked in this order, but switch it and you will see that those had more dates were happier. Sure, I got it. So it does matter the order in which you ask questions. So check your understanding. I think this is the last thing we're doing. Yep. Each of the following is a possible source of bias in a sample survey. Name the type of bias that could result. What are the types of bias that we've already talked about? 2 types. No, not the types of samples. Those are bad sampling methods. Under coverage. And non-response. Okay, so those are the only 2 that we've really talked about. All right, so we're going to look at A, B, and C, and we're going to figure out which one it is, either non-response or under coverage. The sample is chosen at random from a telephone directory. Why is it under coverage? Not everybody is in the telephone directory. Some people cannot be contacted in 5 calls. Non-response. Why is that? Why is it non-response versus under coverage? Right, they've already been chosen, they're in the sample, and then they choose to answer. I mean, don't choose to answer. Interviewers choose people walking by on the sidewalk to interview. Why? Exactly. What if people drive? You're only getting the walkers, you're not getting the drivers. Good job. Good job. You feel smart now? It was right, though. That's exactly why. All right, a survey paid for by makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. Here's the actual question. Oh, it's not like y'all don't want food, do you? Sorry. Sorry, I forgot. As soon as you knocked, I knew what it was. What is today, the 14th? Does it look
I don't
exciting?
ban disposable diapers, but I use the heck out of them with my daughter.
AP stats. Or, no. Thanks. Crashing Zoom. It's estimated that disposable diapers account for less than 2% of the trash in today's landfills. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for about 21% of the trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? Explain how the wording of the question could result in bias. Be sure to specify the direction. So that's the, y'all, on your test, a few of you forget the second part of questions. Make sure that you answer every part of the question, okay? Specify the direction of the bias. Is it under coverage or an overestimate? I mean, sorry, is it an underestimate or an overestimate? Okay, that's the direction. It's one or the other. So tell me, explain how the wording of this question could result in bias.
Because it kind of doesn't defend these disposable diapers because it said that in contrast, beverage containers and stuff.
So here's what it is. 2% seems like a low count, right? Yeah? Compared to what?
21%.
Of other trash or other waste. So the wording made it seem like 2% really wasn't that much at all, right? 2% compared to the 21. Maybe we should ban the other 21% and not worry about the diapers, right? That's how I felt when I read it. Okay, well, what direction would that be? So people are less likely to not ban disposable diapers.
Like less likely to not ban them and less likely to ban them.
Sorry, I wrote dyslexia. Less likely not to ban is what I should have wrote. They're not going to ban disposable diapers because they don't feel like they take up room in the landfill. Got it? No. All right, everybody good? All right, I'm gonna stop sharing, stop recording.